right. Hey, everyone. Good afternoon to all who are here. This is a much larger crowd than I expected for a late afternoon talk. Unfortunately, some disclaimer first, I wasn't able to get a PowerPoint up and running. So there's a PDF. There's some bare minimum animations that are not going to work, but it's the material's the same. Anyways, before I get started, a quick round of intros. My name is Mike Xu. I head up data analytics for the KYC business at Moody's Analytics, which many of you may know as the ratings company, but we do have a software arm as well, where we provide a lot of risk management and risk insights software and data sets for various enterprises. So today we are going to talk about how to efficiently scale your data team. And so we're gonna really talk about three things today around data teams and what they are. So that being part one, which is the why, right, of scaling the teams and not growing them, right? We'll talk a little bit about what that means, why, the rationale, the philosophy around some of those ideas. The what of how we at Moody's KYC are building and scaling our data teams, which is really to build a modern data community. Hands up if you have seen that term anywhere from any of the large cloud vendors. All right, okay. So we'll talk about that, our goal, and what being the goal of what we want to build. And lastly, we'll talk about the how part of building out data teams, which is our idea, or not our idea, but Zhamak Dehghani's idea of building out a data mesh, right? So from a philosophical standpoint, I tend to like to sprinkle in a little bit of pragmatism to building data meshes and how to air data leaders like yourselves away from being too ideological and too ideals driven, right? In terms of building out a data mesh. That would be the three main parts of our talk today. And do pardon me, I cannot step away from this podium, otherwise I would, but again, this is not PowerPoint, unfortunately. Okay, so this is what growing a team looks like to me, right? Philosophically, what that means is if each dot were to represent a single person on your team, and each color, here being one color, right, represents a specific skill set or persona around what the team looks like. And you can think of each kind of row here as kind of a different type of duty or a different type of task or job to be done, right? This is what growing a team looks like. It's really adding a lot of the same skill sets to work on slightly tangential problems, right, in data teams. And the recourse to any problem is to add more of the same skill set, right? So a lot of times you're throwing bodies at the same problem. To me, what I've seen from my own experience is teams where you get 10 data scientists, 2 of them are doing data engineering the only way they know how to do that, right? 2 of them are training models, others are deploying models the only way they know how to do that. Nothing wrong, right, with doing any of that, but sometimes you do have to think about efficiency and whether or not that is the right solution to the right problem, right? So to me, scaling a team is really about bringing in more diversity, bringing more color in terms of different kinds of skill sets, different perspective, different solutions to the same problem, right? And really having each slicing and matrixing of different groups of people to work as efficiently as they can, instead of throwing hammers at every single problem, right? In which case, all the problems will look like nails. So scaling a team to me really means finding the different skill sets, making sure they're well arranged to solve problems for your businesses at the end of the day. And I have 2 main themes around scaling data teams today, right? Part one would be this, which is kind of data specializations that has evolved, right? So around a decade ago, when the term data scientist really got popularized, right, and a lot of people came into this kind of a role, data scientists were very focused on being unicorns, right? It kind of started where a lot of them were doing ML research, some were statisticians, some were scientists, so on and so forth. But a lot of data scientists came from a very diverse set of backgrounds. And they started training machine learning models. They were developing, regression models, good old regression, linear models, right? And they were doing ML research to a certain degree. And then slowly, this crept more and more onto the shoulders of these data science unicorns, where they suddenly found themselves needing to deploy models as services because ML engineering was not well defined back then, right? Some data scientists branched out to start wrangling and transforming data. That's the data engineering side of things as we know now, right? But roll back 10 years or a little bit over 10 years ago, these specializations weren't developed yet, right? And worse, some data scientists really branched into developing apps, software applications, web applications, as implementing business logic on various low-code, no-code tools, maybe. But at the end of the day, what I'm trying to say is a lot of the data specializations that we know now, today, right, was developed out of this evolutionary process. And if you're a data leader that grew with this evolution, you sometimes need to take a step back and think about whether or not you're too stuck on data science unicorns, or you have rationalized some of these data specializations that has grown out of a decade of evolution, right, in the data world. And once you get kind of diversity and different kinds of skill sets working together, a very important part about doing data science, data analytics, which to me is a social activity at the end of the day, right? I see myself as a pragmatist. I think a lot of what we do in the enterprise at the end of the day is solving business problems as a team, right? There are always pockets of kind of your lone wolves or people who are single-handedly transforming your businesses and so on and so forth. But at the end of the day, by and large, data analytics is a team activity, right? Where we come together and try to solve the business problem. And what's the most important part about business activity or team activity is, for me, communication, right? And Conway's law, raise of hands if you've heard of that law before, right? So the law says, and this is not an exact quote, right? You get the kind of softwares that you arrange your people to communicate in, right? More or less, I don't remember the exact quote. But as a team activity in the data analytics world, it is paramount for us to remember each column here, I'm gonna define each column of dots here to represent people working on the same business problem. Each row here to represent people that generally are applying the same skill set, delivering the same outputs, right? Delivering the same tasks for the business, and the whole box around all of these people as kind of the team. And it is very important that as data leaders, we encourage and be explicit about how communication is done across all of these different dimensions, because they're all important and the communications are all a little bit different. We will talk about what each of these kind of communication loops and boxes look like in a little bit, but I just want to say Conway's law is the why of why communication is a core part of scaling out your data teams, right? Okay, and let's take a step back and now think about what communication loops look like when you have a data team that you are very focused on growing and not scaling, right? You'll get a lot of the same skill sets, trying their best to solve problems based on their knowledge, right? If you ask a data scientist to go build a data pipeline, they will import pandas and do all the transformations on pandas, right? That's natural to them. That's the skill set they generally know. Obviously, I'm overgeneralizing, right? But the idea is if you get people of the similar skill set and background to do one thing, they will do it the best way they know how to, right? And the communication loop, even if you force them to talk to each other, to talk together, to work on the same problems, they will come out with the same answers, right? And that is both diversity and also kind of Conway's law of how people communicate in groups, right? And On top of that, data teams do have to communicate with non-technical people, right? They are people outside of your data teams. They could be your stakeholders, they could be your business executives, could be your CEO, could be whatever, which is why I represented that with a tiger. You don't know, it's the jungle out there, right? And you don't know who is supportive of your data team's work, who is not, who is against you, who's your ally, who's your friend, so on and so forth. But nonetheless, communication, I think, is the most important part of that. And to empower a unit of data team on the right here to kind of communicate with the outside world and empower them to communicate correctly and precisely, I think is one of the more important things to enable scaling of data teams, because this will allow different units of teams to communicate with all kinds of stakeholders. And so that brings us to building a modern data community at Moody's here, because a very important part to solve that communication gap between data teams and non-data teams, right, is to get to a proper tooling and a proper set of technology and platforms to allow for data to A, be shared and produced, and B, be consumed by data teams to solve a business problem at the end of the day. And the data mesh philosophy from, again, Zhamak, gave us very good vocabulary and terminology to kind of rationalize and think about a lot of these things, right? So if I overgeneralize the non-data teams to be producers of data, right? Those are the things like users interacting with applications. There are things like your business analyst trying to jot down a couple of notes, emails that your sales team sends out, so on and so forth. Data at the end of the day is just digitized information. So any piece of transactional information that goes in or out of your business is your data, right? And they're produced in a multitude of ways. They're generated, they're shared. They may not be captured well, but they're always generated, right? And on the flip side, your data teams, being a lot of times the data consumers, wants to leverage any and all information possible to produce insights, to help your business solve problems one way or the other. And what is in the middle is data technologies, which has also evolved a lot over the past decade, right? We really started with SAS a decade ago, at least for me personally. I went from SAS to Python and R, right? And Pandas developing, and more of Spark developing. Then Hadoop and Spark came along, blah, blah, blah. And today, here we are, boom, right? A lot of the data platforms have been well commoditized. A lot of the data platforms have branched out into all the kind of different data specializations and capabilities, which leads us to understanding how we can use data platforms to build a technological gap to bridge between data producers and consumers, right? So at Moody's, our data community really looks like this, right? We'll ignore the tiger for a little bit for now, right? And we elected Databricks, or the data intelligence platform, to kind of be a transactional bridge between communications between data producers and consumers. And our consumers, because of the need for us to have role clarity and well-defined tasks, inputs, and outputs, and how different personas interact and work on common business problems, our data consumption side is defined very clearly as data scientists, ML engineers, all the common data roles that you know of, right? And what we mean by that is really helping focus all the functional roles and specializations so that we can also educate the business about what a data engineer does, what a data scientist does. This also helps with the communications within the team, right? So that squads can interact among themselves to talk about how I can solve problems and which part of which problem is done by who, so on and so forth, right? I'm not gonna go into every single box here. This is just a referential diagram to say, data engineers are the ones, right, making data usable. They're the ones who takes in data from any sources, multiple sources, analytics engineers. Personally, I see them as a subset of data engineers, but that's a philosophical debate. We don't have to go into that, right? Are the ones that are really transforming the data to make sure that they are producing the business metrics, the business value, the business data set that the business needs. Data science are the ones both doing descriptive statistics on the data analysis side, as well as kind of predictive analytics or machine learning by developing and training machine learning models. And you've heard a lot this week, right, from other leaders much more knowledgeable than I do, that governance is becoming more and more of an important factor in all of this, right? So 10 years ago, you could just train a model, generate a pickle file, throw it somewhere, and be done with it, right? Whereas nowadays, you really do have to understand the lineage of how the model was developed, how the data was transformed, what was used, what was not, so on and so forth, right? So both the platforming aspect, which helps standardize governance, and the actual governance aspect becomes more and more important in formulating a holistic and cross-functional data team. Okay, and how we communicate, again, here at Moody's, is we carved each of these communication loops and gave it a name, right? Again, borrowing a lot from the data mesh philosophy. Where you are project-based, we call them squads, and we empower those squads to be as nimble and agile as they can be, and empower them to make decisions for themselves in order, at the end of the day, to solve the business problems, right? And we allow our data scientists and engineers to be fairly flexible, right? In the sense that we talked about the tasks to be done by each role, but we don't want to limit every engineer's growth. So we want to make sure that data scientists can learn a little bit about our orchestration and data pipelining. We want to make sure that the data engineers can learn a little bit about the ML libraries and methodologies. So that's the squad level communication, where it's really empowered to focus on the business problems. We have guilds, which is to help kind of standardize and translate different tooling across different projects that are focused on one particular technical problem, right? So that there is knowledge sharing across all of these personas that's doing the same thing. And ultimately, we have that box, and we call it a team, where the focus is on building camaraderie. It's on building kind of trust and belief in each other. It's building domain knowledge. It's building out kind of know-how and team interactions, right, so to speak, to have a sense of belongment for our team members. And those are all explicit kind of communication loops that we enforce to ensure that our team members are constantly talking to each other. And in order to scale out that communication pattern, I want you to now to think about, hey, when you're introducing a new team, how does that work, right? I do think my diagram here is it could have been a little bit better in the sense that the squads should be able to spread across multiple teams, right? Because it may just happen where you need to solve a business problem that stretches across multiple different domains, multiple different skill sets, so on and so forth. But having explicit communication patterns for each of these kind of mode of operations, right, really helps us rationalize how the organization structure would influence how teams interact and communicate and solve problems, right, at the end of the day. And so the what part of what we do, right, here at Moody's at the end of the day is to empower the right communication, and having all of this really helps build a modern data community. For us, teams are centralized to have an opinion on how things are done. They share a reporting line into a common manager. Squads are federated so that they operate with guidance, both from the functional guild as well as from the individual data teams. And squads also share a project focus. Usually they're cross-functional, but we're very flexible in the sense of, depending on whether or not the project requires more of a data science attention where we need to train a model versus maybe there's no data science component at all, where they just need to build data pipelines. That's when we have more data engineers, and so on and so forth. And lastly, we have guilds that are meant to be decentralized so that the individual engineers and data scientists on the teams are able to contribute and share their opinions, tech stacks, contribute to best practices, and also just grow a diverse set of skill set across the organization, so that as tooling evolve, right? Uniform didn't exist until, a year back. And in 5 years' time, there is likely going to be something else, right? So we want to make sure that we can decentralize knowledge as individuals do grow and learn at a different rate. And this helps ensure technical depth and domain knowledge. And we have a communication loop to support all of these kind of interactions, so on and so forth. And then if we zoom out one more level, right, we get to the how of what we are trying to accomplish, which is building out a data mesh to support all of these kind of communication loops and patterns, right? So in the event where one data team becomes 4 becomes 8, and your stakeholders goes from just marketing and sales to product development, to your executives and so on and so forth, right? The right way to support that is really to build out a data mesh, right? Philosophically speaking. And we'll talk about what that means in a little bit, right? So data mesh is a mechanism for really democratizing, right, your access to data and AI. And what that means in the producer, technology, and consumer paradigm is that, again, the data producers produces data into a common technological platform. And the data consumers are the ones that are refining the data into data and AI products for internal use, for your clients, for external use, doesn't matter, right? But democratization, right, at least to me, means you need to build a system or an organization, a communication loop, different kinds of role clarity to support this model where everyone is contributing collectively to building out data products. And there are quite a few, I'll say, different solutions, right, to building this paradigm out. We'll talk about it in the next couple of slides. I don't think any of them are right or wrong, right? I think all of those solutions are circumstantial. We'll talk a little bit after the solutions on what makes it practical, what makes it pragmatic, and what is the best choice individually for all of you, and my personal thought processes behind making some of those decisions. But solution one is to centralize, right? And I think this is a fairly simple solution where you can just say, let me just put everything and force everyone onto one place, right? It can work, absolutely. And in fact, it has a lot of benefits for a data team that is built out this way. You have really high trust. They are working as a singular unit as one team. There's generally significantly lower friction, right, in data production and consumption. What that means is because it's one technological platform, one set of producers, one set of consumers, they can talk among themselves and they can just get things done. And everyone generally have access to everything, which is not great for governance, but this is one solution to the problem of how you can communicate and build a collective data organization. There's option two, which is to decentralize, which is also fairly easy, where you can just say, here's the dividing line, here's the line in the sand, don't touch each other ever, right? And what you'll get out of this is silos. But silos, centralization, decentralization, for me, all of that is just a perspective, right? Because in this diagram, for example, if you zoomed in to just one of the silos or one of the units, right? That is actually just a centralized unit at the end of the day, right? So individually, when you decentralize, each box is just a centralized data team, and it has all the benefits of that. But when you zoom out, you really realize that all of a sudden, your data assets and your data domains are highly fragmented because there are boundaries and lines between all of them. And again, I don't think there's rightness or wrongness to this. Different businesses and organizations have different needs and requirements of where to draw the lines and draw the boundaries. But at the end of the day, if you as an executive zoom out, you will realize that now you have tool fragmentations, you're paying redundant licenses, you might be buying the same software 5 times, so on and so forth, right? And if that is a conscious business decision that is to be made and is correct, so be it, right? But rationalizing the centralization and decentralization of all the data teams is an important part about making a conscious decision of what is right for your organization. And in this case, data sharing and production, again, across different teams is gonna be highly difficult. But at the same time, within each team, you reap all the benefits of centralization. And for us, we kind of took the third approach, which is to build a data mesh on Databricks. Again, data mesh philosophically, and Databricks is our execution paradigm, where we want to say, we still want to keep some degree of separation between business concerns, because different businesses may not relate to each other exactly the same, right? So for us, that manifests as multiple different products, where the products may not be talking to each other that well, right? And they may not have a common user base, and they have completely separate user bases, and so on and so forth. At the same time, we want to make sure that internally we have as little redundancy and inefficiencies as possible. So we elected for a common data technology, right, in the middle, which is that middle box. Now, at the same time, we do not want to give everybody access to everything, right? So the right way for us to have meshed it out was to say, let's put some governance and controls in place, make sure that there are some boundaries within the data technology box, and to ensure that everyone have the right access to what they exactly need. And this is kind of a middle ground solution. Again, right or wrong is up for debate, but it does have medium trust in the sense that there's still boundaries. If you need to get something done, if you need to get access to new data sets, you might still need to ping somebody, be blocked for a little bit, and wait, right? And how long that wait time is, you can always fine-tune that as an organization, but there is still some friction in terms of sharing data and consuming data, right? And again, that is a conscious choice. But at the end of the day, this gives us a solution to share data, because it is one technological platform, and we require minimal stitching. And for us, again, that is done through Databricks, because it does have the ability and capacity to do most of the data specialized tasks that needs to be done nowadays, right? So in order to achieve this through Databricks, we really broke down our different data personas. Again, it's listed there, into different components of the data intelligence platform to use. This is definitely not exhaustive, right? And it's not an exact science of mapping, but generally data scientists have an access pattern of using notebooks plus compute. Your ML engineers wants to do ML ops, which is ML flow in Databricks. They want to be the ones using feature stores, feature and vector stores. They want to use the model serving features. Data engineers wants workflows, DB SQL, Delta Live tables, so on and so forth, right? So Databricks components and constituent features, right, really helps the idea of bringing role clarity to data teams, in the sense that their tools are each designed to be focused for different data specializations that evolved in the past decade or so, right? So being data leaders, if you can be clear on all of this and support all of the execution for these different personas by introducing the right communication loop, I think that is a very powerful tool to implement, right? Now, but the flip side of that is, if you do not have role clarity and you do not have kind of the tooling clarity, then you might end up having data engineers clicking into Databricks and going, what is all of these playground and feature stores and stuff like that? They may not know. And similarly, Your data scientist might go into SQL editor and say, I don't want to write SQL, right? So on and so forth. So a lot of this is dependent on good data leaders to build out all of these clarity and communication loops. So you might ask, I heard you talk about the, why, what, and how, and you might ask, what's pragmatic here and what's practical here, right? And my message to you at the end of the day is different organizations, tech, non-tech, anywhere in the middle, they are organized in very different ways, right? Raise your hand if you have seen this meme of how the big techs are organized, right? So it's very diverse how different companies organize themselves. And my plea to anyone who is willing to listen to me here is that there's always no idealistic right or wrong. There's just what works, right? And it's very important for data teams to remember that data teams is a proxy to your organization at the end of the day, because data is generally produced by how your business is organized. So don't fight it, right? Go with your business, go with how your business is centralized or decentralized or federated, and just make sure that you think about data teams, units, to be able to produce as efficiently as possible benefits and progress for the business at the end of the day. Scaling, not growing, is very important, right? Scaling efficiently to make sure collaboration, communication loops are all well taken care of, role clarity is taken care of, really helps. And don't focus that much on growing empires, right? Because as you grow your empires, they may not become efficient. They may just actually be a hindrance to the business a lot of times. That's not good for anybody, all right? So to be practical, take a step back, think about exactly the roles you need or the role you're in, and so on and so forth, right? And lastly, that is a point I mentioned. Just go with how the business is divided. Don't fight your business. Always follow your business paradigms on carving out the right data teams. And if you fell asleep through all of that presentation, I tried to summarize my own points here at the end of the day. This is also kind of what I use to remind myself of what to do on a day-to-day basis, right? Number one, scale the teams. Don't just blindly focus on growing them, especially don't focus on just growing one persona. If you are a data leader that is kind of fixed in a specific persona within your organization, I think that is okay. Then it is also your job to work with other data leaders in different functional roles to identify the right communication loop and the right way to collaborate and work with each other. Do not hunt for unicorns. They do exist. There are quite a few that I know. There are great unicorns out there, but don't hunt for them because the data world has evolved in the past decade to really focus on specialized tooling now. A lot of the specialized tooling are all commoditized by Databricks and others, right? So use them and don't go look for the unicorns out there. Databricks has mostly everything that you might need in a modern data team nowadays, and also for data production, right? So use that. Having role clarities help everybody accomplish their jobs better. Communication loops through squads, guilds, teams. If you're looking for words to describe those communication loops, here's some, but you're always welcome to come up with your own that fits your organization the best. And lastly, it's all communication. It's all Conway's law, right? Communicate, 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 but be specific on how, why, what you communicate in different circumstances. And the last row of kind of principles here is my personal opinion, right? Personally, I enjoy, or not enjoy, I think centralizing technology is highly efficient for licensing cost reasons, for kind of fragmentation reasons. I think content really needs to be federated so that each group have their own ownership over the content and the data assets that they put into the centralized technology. And for ownership to be completely decentralized in the sense that everyone has the accountability and responsibility to themselves to put in good quality content, right? And own up to the content when it doesn't work. And that is all I have for today. Lastly, if this is a kind of working model that you think you might enjoy, do check out some of our careers at careers.moodys.com. I do not have a QR code here, but that is all for today. Thanks for listening.